toward so if you look in the practice sets, there's a couple different versions of this that are available. Couple different examples of reconstitutions. If you're at Allegheny campus, this is not the reconstitution question you'll see, but it's good to know this because you might see this on an NCLEX or on your NCLEX coming up here soon. So or sooner than you think. So when we look at this, a couple things you want to pay attention to. First of all, a lot of times the trouble or the challenging part of a reconstitution problem is first even realizing that that's what you're dealing with. So if you're at like north, south, Boyce, a lot of times you'll get a question that looks like this, and it'll just tell you how much would you administer for one dose. And you don't know what they're looking for. Are they looking for milliliters? Are they looking for tablets, capsules? What are they looking for? So a couple things to keep in mind. If we're dealing with an intramuscular injection, it's milliliters, right? Because it's a fluid. Okay. So that's how we get that medication in. Okay. If we know that it's intramuscular, then we know we're dealing with an injectable, and we should know that there must be some sort of like strength per milliliter. But when we look at our cefazolin or Ancef, we can see that it just says 500 milligrams. It doesn't say anything about milliliters anywhere on the big part of the label. So that's your clue that you're dealing with a reconstitution, is that the label doesn't tell you what the strength is. So you need to go to the directions on the side label. Okay. So what you're going to do is you're going to look and you're going to try and figure out, okay, well, what is the strength of this particular medication? So when you're looking through this, and each reconstitution question is a little bit different, but when we look at this, it tells you that the usual adult dosage range is 250 milligrams to 1 gram. This is 375 milligrams is the order, so we're good. Intramuscular, that's what we're doing, right? It says to add 2 milliliters of sterile water to the powder, shake well, and once you do that, you're going to get an approximate total volume of 2.2 milliliters. These two things don't really tell us anything new. It just tells us what was done and what we came out to be total wise. What I'm looking for on this is this, what I'm circling right now, that 225 milligrams per milliliter. That's your strength for this particular medication, this reconstitution. Once you know that, then it's just a matter of 375 milligrams, milliliters, 225, 1. Now, I think at North, they like it that you start with milliliters first. So if you just switch these two around, if you do the 1 milliliter over 225 milligrams times 375 milligrams, we're writing the same thing. I just write it. I usually start with the order, and that's my preferred method. You're going to come up with the same answer, which is 375 divided by 225, 1.66666666. So that would be an answer of 1.7 milliliters. So like I said, the tricky part with reconstitution type questions is knowing what it is that you're working towards, or how to find the strength and the concentration on the label. So it's about figuring out that information.
Thank you.
You're welcome. Good question. And also I should say, like this, what I'm looking at right now, it's in the Boyce folder. So Boyce and North kind of overlap. So does Allegheny and Boyce, or Allegheny and North. But if you look in the Boyce folder, this is the 230 study guide. So it is 230, but it's still applicable to you guys for 240, including there's some additional practice problems for the heparin protocol, as well as converting micrograms per minute to milliliters per hour. And then I've also worked through these. They'll be they're posted up on YouTube. The ones I did on Tuesday, and then the ones I've done today will also be posted up on YouTube once, either later tonight or tomorrow morning. All right. So someone said number 21. Just see who said that. Okay, so that's the Allegheny study guide, I imagine. So let me change my thing here. Okay. So 21, the challenge with this question is, and then please correct me if this is not the same 21 that you're referring to.
Yeah, it is.
Okay, good. I'll make sure I'm on the same thing. So the trick with this one is knowing that there's extra information in here that you don't need in order to solve this equation. When I'm looking for flow rate, I need two pieces of information. I need the volume and I need time. That's all I need to calculate flow rate, okay, or drop rate. If we're talking about flow rate, milliliters per hour, if we're talking about drop rate, drops per minute, and the way you know whether or not you are dealing with a drop rate question is if they give you a drop factor, they mention microtubing, those are your indications that you're dealing with a drop rate question. At Allegheny campus, we ask you, what is the correct drops per minute flow rate? So we can get a little bit more specific with our questioning. So here it says the patients receive Solu-Medrol 200 milligrams IV. That's important as far as making sure we're giving the patient the right medication and the right strength. But as far as calculating the flow rate, I don't need to know that, which is why I crossed it out. So I look at my or I look at the rest of the problem. It tells me 120 milliliter IV. It's going to diffuse over 30 minutes and a drop factor of 10. Go ahead.
My question is, if it's giving it 30 minutes, like, do I have to convert it to hours and then minutes? Like, does that make sense?
Correct. Yeah, no. In fact, don't do that because it's a waste of time, right?
Okay.
Because your end is already in. And I apologize for saying all that extra stuff. This is usually what trips people up, which is why I was saying it. But yeah, if it's already in minutes, leave it alone. Don't go to hours, because then you're just going to convert it right back to minutes. Good question. All right. Any other questions that you like I said, if you've gone through this and you feel pretty good about it, but if there's a few questions that you have questions on, just let me know and I can bounce between any of the reviews that are available, the practice tests that are available.
Do you know for the Allegheny campus if we have to know like titrations and the reconstitution stuff?
So you don't have any titrations. You do have reconstitutions, but it doesn't look like what I showed you previously. Your reconstitutions are going to look like this. Pretty sure you have some. Maybe not. Maybe that's not in your in your thing here. So I will tell you that this right here, like number 12, that's technically a reconstitution question. So it is, there's no label or anything, and then it tells you like what the strength is, but technically this would be an example of a reconstitution type question. And then, yeah, I don't think you have any titration questions. You shouldn't. Okay. Okay. Yeah. So heparin protocol, absolutely. All right. So let me so you should remember doing this from last semester. So let me just clear out a few things and we can do this fresh. And I'll show it to you both ways. I'll show you the way that you need to do it for Allegheny campus, and I'll also show it to you the way you would do it for North or any other campuses. Which is why I've worked this out a couple different ways. Thanks for being patient. Almost done. Okay. So you should recall from the last year at the Heparin protocol, it's just a matter of figuring out what is important, right? So you're, I always say like what I started doing this semester with prep, this is your available. This is your order. And then this is your weight. Okay. So let's change this up. Let's make this patient's weight. Let's just make it a different value. Let's make it 185 pounds. Okay. Now, the way I usually teach this for Allegheny campus is just to go ahead and just convert this to kilograms, but I'll also show you the North way divided by 2.2. So you'll get 84.0909. So this would be 84.1 kilograms. I do believe at North, they want you to not do that. And I'll show you how most likely how they showed you how to solve these types of problems just as a review. All right. So as a reminder, because you have seen this question before, similar question before, they're going to ask you two questions. They're going to ask you to calculate a bolus, and they're going to ask you to calculate an IV drip, okay, or an infusion rate, a flow rate. There, in the practice, I gave you four samples, but in reality, you're just going to get two. You're going to get one bolus, one flow rate. So it's either going to be the initial bolus, initial flow rate, or after reassessing the patient, checking their APTT, and then the new bolus, if applicable, and the new flow rate. So we mentioned that we have a patient and they are 185 pounds. It's going to be important to know for when I write this out for we'll call it the North version. If I'm doing this Allegheny, I'm going to take that 84.1 kilograms. I'm going to multiply by my 80 units per kilogram because that's what the order told me to do. And that's going to give me 6,728 units because we canceled out kilograms. Then I'm going to convert units to milliliters using the bolus dose strength, which is 1,000 units per milliliter. And remember, I'm not making that up, right? That's right here. It tells you right here, bolus dose strength, 1,000 units per milliliter. So it tells you. And then what you're going to get is 6.728, which would just be 6.7 milliliters would be your bolus order. If you are doing this and you're at North Campus, they might want you to, they may have shown you to start with milliliters. So you might start with your bolus dose. Then you're going to go through and kind of just work this backwards. Okay. But instead of writing out the value here, you're just going to have your 80 units. Kilogram. Kilogram. Pounds. And then the patient's weight, 185. And what's going to happen is you're going to come up with the same answer. You just arrange the question differently. So if you're looking at this and you're Allegheny campus and you're like, what is going on here? You don't need to necessarily worry about doing it this way. I just wanted to show it since I know that a number of North students have asked about this. So, and then I think that's even how it's done in your review. And then you'll get the same answer, the 6.7 milliliters, even with rounding. And that's why I think when you have an adult or at least someone who's over like 120 pounds, maybe even over 100 pounds, rounding doesn't really factor in as much. It's not as important. It's still important, but it's more important for your pediatric patients that are smaller and those tenths of a milliliter matter. I might just be saying, obviously it always is going to be dependent on the medication that they're receiving and how they're metabolizing it. But as far as whether you round at the beginning or round at the end, at least in this example and a couple of examples I've gone through, it's been the exact same answer. So do with that with what, or do with that what you will. All right. Then it says to calculate the infusion, infusion. So I'm going to do it again. This is the Allegheny style. I'm going to take the 84.1 kilograms and I'm going to multiply by my order of the 18 units per kilogram per hour, because that's what we're going to start our infusion with. $84.1 times 18 gives me 1,513.8. And that's units per hour. But I don't want units per hour. I want milliliters per hour. So I need a way to convert units to milliliters. And again, that's in the protocol, step 2. The IV that we have available tells us 250 milliliters, 25,000 units heparin. And so when I do this, I'm going to get 15.138, so 15.1 milliliters per hour. So the takeaway from this is that the main thing that's going to change is the patient's body weight. So that the body weight might be given to you in kilograms, but if it's given to you in pounds, just make sure you are converting it to kilograms. Just to kind of frustrate you a little bit, Allegheny campus, this is kind of what the Boyce campus version would look like. And then possibly similar is the North campus, is you're going to see your heparin protocol will look more like this, where it'll tell you, bolus, it'll give you the protocol, bolus the patient, it'll give you the availables, and then it'll tell you to calculate the bolus, calculate the IV drip. You won't see all that extra stuff, all the extra, CBC and Gaiac stool and all that kind of stuff. Like you won't have to worry about seeing that. But hopefully after you've done this a couple of times, you realize, oh, okay, it's just a different version of what we're looking at. So I think someone, yeah, you're welcome. All right. Yeah, and then if you go to the 222 or the 230 study guide that was put together, even though it's a boys, you could see there's variations of heparin problems. So it's good practice. So if you want to see it, the key to this is at the bottom or at the end of this document. So you can go through and you can practice these if you want, just to get a little extra practice. All right, so I'll ask again, if you have any questions or if there's something you want to look at, just let me know. Question on the study guide or the practice test, just let me know. This. So they'll have it's dopamine infusion going from 5 micrograms per kilogram per minute. You have a patient's weight in kilograms, and then you have the available dose. So it looks like it's a suspension problem. So in this instance, with this question, you actually are using all the variables. You need to account for the patient's weight. So 70 times 5. Then you need to, once you get to that, then you need to go through the process of converting your micrograms to milligrams, minutes to hours. And then that way you can compare it to the milligrams per milliliter. But because I know you're at North, let me show you, we'll just call it the North way.
Yeah, we seem to be different up there.
Yeah. And you're just doing, it's a strategy. And if they can get you to be consistent with a strategy, at least like if you need help, this should help doing it this way. So nothing wrong with what they're asking you to do.
No, and I think it does help because I'll look at a problem and someone will try figuring it out opposite and it'll confuse me just because I only know it like in that one particular way. So I'm like, no, I need to figure this out myself going from this way to this way.
Mm-hmm. Well, all I can tell you is what I'm going to show you and like the way that I usually do it. I just do it I always usually start with the order. So like, that's my kind of like my starting point. I say, okay, what's the order? And then I go from there. Or I'll say, if it's a weight-based problem, I start with the weight first. Then I incorporate, so it's weight times the order and then my conversions. But I'll show you the way that you've been taught. I won't say it's your way. It's like I said, what you've been taught at North, and I'm only just figuring this out this semester. So you're going to start off with your milliliters, and this is a good strategy actually, because if you start with milliliters, you know that you are looking for an infusion, right? The only thing you may not know is, well, what type of infusion are you looking for? Are you looking for drops per minute or milliliters per hour? The fact that there's nothing here that says microtubing or anything like that, that's your clue that you're dealing with milliliters per hour. So that's what you're looking for. So start with milliliters. Now we want milliliters per hour. Right now we have milligrams. So I need to do something with getting to my per time. I do have a 5 microgram per kilogram per minute, but the problem is this is in milligrams. So the next step would be convert milligrams to micrograms. Now, so now we've eliminated milligrams. We're in milliliters per microgram. Now we can take that 5 micrograms per kilogram per minute. And now we're in basically milliliters per kilogram per minute. Get rid of the kilograms.
Now, did you multiply that kilogram per minute there?
Yeah, so that, I mean, that's just how that would be written. Some people write like a slash here, but it's kilogram minutes. So there's 2 units there.
Okay.
Yeah. So 70 kilograms is just over 1. So now we've eliminated kilograms. Now I'm in milliliters per minute. And the last step is just converting minutes to hours. And then once you do that, you should get an answer that is 13.125, but then we would just round that to 13.1 milliliters per hour.
Did you get a crazy billion number for the top one?
Oh, let
Or
me see.
million number, I'm sorry.
Yeah, so 250 times 5 times 70 times 60. Yeah, 5,250,000. And then divide by 400, divide by 1,000.
Okay, that's what I got. I think the big numbers, when I see something in the millions and billions, like for the heparin and stuff like that, I think it always just scares me because I'm so
Yeah.
afraid I'm going to get it wrong.
Yeah, it ends up being a lot of zeros. So the good news is you get to use a calculator. So just, if you just keep plugging in and like do your division and things like that, it should work out fine. And then do it do it maybe 2 or 3 times just to make sure you're getting the same answer each time. And you should be okay. And then I will say, I'll encourage you to also go to the the 220 or the 230 study guide for in the Boyce folder. And then she put together some questions that are very similar, where you have the micrograms per minute going to milliliters per hour, micrograms per minute going to milliliters per hour, and even here, micrograms per minute going to milliliters per hour. And then I guess I work this out. And so I'll just leave it as it is, so you can at least see. And there's a blank version of this as well, meaning like not marked up. And there's a key at the end of it as well. So that way you can kind of practice and make sure that you got it down.
Okay, perfect. Thank you.
Yeah, you're welcome.
Now, where did you email this to us, or is it on our Blackboard or something? Like,
how did you get the Zoom link?
they emailed that to us.
Right. So in that email, there should have also been like link to my YouTube page. And then and there should be another link that says click here for practice tests.